This video will demonstrate how to make an expression that invokes a callable. Callable means anything that can be called. That includes functions, pointers to functions, and a few more things that we'll see later on. Here's the basic structure. You make an expression that invokes a callable, which has one callable, and we'll show some alternatives for that coming up, followed by 0 or more actual parameters. For this example, I'm going to use one actual parameter, an integer literal whose value is 3. That will be common across all the examples, and the only difference will be what is the callable. So in italic is what is the callable that precedes the left parenthesis. The first one you're going to see is a non-member function that takes an int and returns void. The callable is the name of the non-member function. You've seen the invoke a callable, you've seen the actual parameter. What's new here is the callable. It is an expression that represents a use of a non-member function. That Semel has a one-to-one association and says, which non-member function am I using? And the answer is the one whose name is NMF. The callable has the type of the function, which in this case is non-member function that takes an int and returns a void. You can also invoke a per class member function, a static member function, and from anywhere the callable would look like name of the class, : name of the CMFPC is my abbreviation for class member function per class. And the callable will be an expression that represents a use of a CMFPC, which says, which CMFPC? This CMFPC, whose name is a CMFPC. And again, the type of the callable is function that takes an int and returns a void. What if you have a member function calling another member function? The callable would simply be the name of the member function you want to invoke. There is an implied this arrow here. Since it's implied, we don't see it or show it in the Semels. And the callable here is an expression that represents a use of a CMFPI, class member function per instance. And which CMFPI is it a use of? That one, whose name is a CMFPI, and the type of the whole callable is function that takes an int and returns a void. What if you want to use binary dot to indicate an instance to your left and the name of a CMFPC on your right? In that case, the callable is an operator binary whose operator is dot. The 0 operand, left operand, is a use of a local variable. Here's the local variable. It doesn't have to be. It can be any expression whose type is instance of this class. And then operand 1, the right operand, is simply an expression that represents a use of a CMFPC. And the type of the whole callable is still function that takes an int and returns void. Very similar to that is an expression where you use a CMFPI rather than a CMFPC, and the only difference is it's per instance, and per instance. Again, the type of the callable is function that takes an int and returns a void. Arrow is very similar. The only difference is that the operator is arrow, and the left operand, operand 0, must have type pointer to instance of a class, which it does. And again, the callable is function that takes an int and returns a void. Very similar to that is arrow with a CMFPI. The left operand is the same as it was a moment ago, the arrow operator, and then a CMFPI instead of a CMFPC. Again, the type of the callable is function that takes an int and returns void. The next one is a little tricky. What if you want to have a class which overloads operator parentheses? You might have heard this called a functor, function object that goes by several names, either one. So make an instance of the class and follow the name of the instance with paren3 which invokes the instance. So the callable is an expression that is a use of a local variable. Which local variable? This one. And it's very tempting to do it this way because if you make these semels and codify them, they will show up looking just right. However, these are not the best semels for the job because if you have multiple overloads of paren, nothing in the callable identifies which overload, which has two consequences. There's no way to know if the number and type of actual parameters are correct, and there's no way to know what is the type of the expression that invokes a callable. Is it void or is it in? So for this reason, we have a little bit more work to do when you want to use a functor. You make an expression that is a function object whose operand 0 is the use of the local variable. That's this much. But it also says which member function per instance will I invoke. And that is a use of a CMFPI, which identifies operator parentheses, which means it identifies this overload as the CMFPI to use. Therefore, the entire callable now knows it is a function that takes an int and returns a void, so it can verify the number and types of actual parameters, and it knows the return type of the entire expression. So this will give you the correct code, but this will give you correct type checking during the use of the Semel Editor. That concludes this video.